Let's continue on this example. Let's pick up where we left off in the last video. We've drawn our cross-section. We've drawn one representational cross-section here, one disk. We've realized that we're going to have thicknesses with respect to y because we're spinning around a vertical line. Anytime we spin in the plane around a vertical line, our thicknesses are going to be with respect to y. And now we need to set up our integral. We know that we are dealing with the volume of a cylinder, so we know we're dealing with pi r squared times h, which is the height. There's the volume of a cylinder. So I'm going to pop my pi out front. My r is going to be squared. My r is the distance from the center of that circle that's the base of my cylinder to the outer edge, which is right here. This distance, according to our variable y, is just our function. This distance is our function, just as if we had gone from the horizontal axis and stopped to the upper bound of a function like we did on the last example, and that was our function in x. Right ear on right shoulder, this is our function in y, and it's given to us very straightforwardly. It's 1 over the square roots of y. So there's r, and we are having thicknesses with respect to y. So it's pi r squared dy. Our height is dy. And again, they gave us our limits of integration, so that's 1 up to 4. So there is our integral. Let's move to the next. Here we are. This is the volume of our disk. It's the volume, this is the volume of one disk, and we're adding infinitely many of those up, starting at y equal 1 and stopping at y equal 4. So again, on our step-by-step process, step 1, draw a picture. Part of step 1 also is draw a cross-section and draw a cylinder so that you know what the cross-section is. Step 2, basically to set up your integrand and your thickness, your with respect to. So determine, are we doing things with respect to y or with respect to x? Do I need to put r as a function of x? Am I spinning around a horizontal line in the plane? Or do I need to write r as a function of y? Am I spinning around some vertical line in the plane? Step 3 was to find your limits of integration. They were overtly given to us. Start at y equal 1, stop at y equal 4. And here we are at step 4. Set up your integral and evaluate it. So we have pi times the integral from 1 up to 4. 1 over the square roots of y squared leaves me 1 over y dy. And so now we're down to the part of calculus we're very comfortable with. We find our antiderivative function. We apply fundamental theorem of calculus. So we have pi times the quantity natural log of 4 minus natural log of 1. We know that's going to 0. So this is pi times the natural log of 4. So a very quick video just to finish up that example. But there's an example of doing things with respect to y. And the secret of success on the disk method is to realize that all of your disks are really just cylinders. Any three-dimensional solid, it's the volume is always the area of the base, just like we did on the last example. Always the area of the base for us. The base is always a circle if we're dealing with a cylinder, times the height. The heights are what's in charge of whether we are doing things with respect to x or with respect to y. The secret to success there is if we are spinning around any horizontal line, our thicknesses are going to be with respect to x. If we're spinning around any vertical line, our thicknesses are going to be with respect to y. Now the two examples I did here are spinning around the axes. The first one was around the x-axis, this one is around the y-axis, but I want you to realize we are going to be doing problems where we're going to be spinning around other non-axes horizontal and vertical lines, and that's where step number 1 becomes super, super, super important. Draw yourself a picture to make sure that you are getting r in terms of your function, because if you're not spinning around an axis, r might not just be the function itself. It might not be just f of x or f of y. It may be something else besides that. So the secret to success on these is to draw a good picture and then follow that step-by-step process. So this finishes this lesson. Come to class next time and we'll work some homework problems.